All right. Oh, great. So I think everybody's here. I think I saw some beers, although they're not allowed. And I thought, how is this talk going to go if everyone is drinking beer outside? But I see a lot of people. Thanks for joining me and choosing me and this talk versus beer. And I think there will still be beer left for us once we finish. So we will try to become Kubernetes masters while still being next to what we as developers treasure the most, our code. It's not easy. It's not easy in Kubernetes world, as we see. We will try to dig deeper, understand why it's not easy, and what we can do to make it a little bit easier. So let's start. A little bit about me first. My name is Ivan, or you can also call me Ivan. I'm kind of used to both of these pronunciations. I work as a software engineer on Google Cloud Platform and Cloud Code for IntelliJ. I'm based out of New York City. What you see here is the tallest building in the US, the Freedom Tower. And this is what I actually see every day from my window. I get a nice apartment. I got lucky. It's beautiful. I also see it every morning as I go out and grab my morning coffee. So come visit us, and today we'll talk about the Kubernetes features of the plugin, where I designed and contributed to many of them. So let's start with a little bit of a story. I think story is good, and we can see through the story how things are unwrapped for these free developers. We'll talk about a tale of free developers and their brilliant idea. Everyone loves a great idea. So their idea was a voting application, voting as a cloud service. They thought voting is so important in the current world. You know, you heard about this, voting, elections, hacking into elections. We got to build something very good and then sell it as a service. And so they decided to do that. They were three friends. And they even created some UI mockup. Very nice. I like it. And the two of them were Java developers, but one got a little bit tired of Java, and he decided to do Kotlin. And since they are going to use containers, everything is possible. So one will be using Kotlin and Gator. Another one will be using Java and probably Spring Boot. And third one will help them on JavaScript front and will use Node.js. So they thought, if we're going to sell our service globally, it should be available 24/7. It should be easy to update. We should be able to do rolling updates and never lose our service. We should use different technologies and still have the full control about the libraries, the binaries, the security, the roles, and be spread across various geographical regions. This all sounds like a great idea for cloud. And the best way to build an application for cloud is cloud-native application. So they dig a little bit deeper. What is cloud-native application? There's a lot of buzz around these words, but it's actually very easy to figure out. These are the two sentences from Cloud-Native Foundation Charter itself, like the core meaning of cloud-native. And it's pretty easy. Let's see. Cloud-native technologies empower organizations to build and run scalable applications in clouds, any of them, private, public, on-prem, and containers, service mesh, microservices, immutable infrastructure, and declarative API is what we use to build them. In red is what matters for us as developers the most. And we'll start with containers. But before, they whipped up this simple design. So the external traffic will be served via Kubernetes Ingress, and we registered a special domain for this demo, and we will buy this cloud service from these three guys for our demo. So this traffic will go to front-end service, and this is where our Kotlin guy decided to use Kotlin, Gator, and build it with Gradle. So it will serve root page, where you cast votes, and results will give you results. And it will call vote service, the heart and brain of this application, the brain microservice, built with Java, Spring Boot, and Gradle. And the final one is notification service. The JavaScript guy will build it. It will use Node.js and use WebSockets to dynamically update results. Great idea, great design. We're loving it. It looks very cool. And I think it's time to dig deeper into how to do it in cloud-native way. So the first thing is containers. We need to put everything in here in containers. So who is using containers here? Oh, almost everybody, yeah. Well, not everybody, but a lot of people. Exciting technology. We can build something, binary, not binary, Java, Kotlin, Node.js, and combine them in a single cluster. Amazing. Definitely, we should use that, set those free developers, and start prototyping. So what do? Like the Java developer, for example, we build our project, and then we need to build an image. But what is here? For each image we need to specify an image repository. Okay, so here is GCR, Google Container Repository. But then the last one, but not least, that's a version number. One of the important things about containers, all of them for a specific version, they are immutable, which is great because we can always reproduce our system by taking images of containers of a specific version. But for us as developers, what does it mean? Every change, every fix, every update needs a separate version number. That's a lot of cognitive load, don't forget. But what happens if you don't update version number? Nothing will happen. Your update will get lost because cluster will not pull the new version. You will not see anything. Then you need to push it to remote repository. And then so you can pull it from that repository. And you need to configure authorization, authentication, and access. And don't forget about version number again. And then we need to deploy, or you can run it locally with Docker. And if you deploy, you need to edit some YAML, apply this YAML, and it's done. Not really. Because once we deploy this, we don't have access to it most of the time. Most of the microservices are internal to a cluster, and it means we need to do even more things. We need to call kubectl API, list our pods, understand the pod name, do the port forward to our local machine. Once we do the port forward, we finally get access to some endpoints which is developed on our local machine. And if you want to see logs that happens in a remote cluster, we call kubectl logs. This is so easy for a single fix, new line of code, just those commands. I think roughly about 8 commands and roughly about 4 different CLI tools. For each little update, you need to add a fix into your cloud native application. If you put your head this way, how does it look? Infinity, that's what they thought. Our developers are really, they're really agile. They like fast iterations. That's what they expected from the microservices application. Different repositories, different GitHub repos, fast build iterations, and quick communication using Kubernetes over the cluster. But here, looks like an infinity. There must be a way of doing this better. They start looking for tools. We'll see, they found one. But next, we talked about containers. So next thing from cloud native is, but before we talk this, that's the small iteration. That's what we thought, right? That's things I care about, things I wish just do not happen for me, just somewhere in the background. That's what they wanted. The next thing, declarative APIs. And it usually means you need to write a lot of YAML. Who loves writing YAML? Not me. Oh, I see. Hardcore guy. I adore you. Congratulations. But, I am not that super strong in YAML, and most of the people I see and most of my team members really enjoy the YAMLs. Look at this. A lot of spaces and dashes and dashes and dash and space and dash. And never forget what comes after what, and never forget where this should be a dash or where should be just another list of properties. This is really, really not user-friendly. And we would love to spend as little time with YAMLs as possible. But the good news are, YAMLs are usually pretty standard. If you develop your deployment, your service, you're starting your workload on Kubernetes, you apply some secrets, environment variables, most of the time you can solve this with a snippet or live template, as we call it in IntelliJ. Just do IntelliJ's live template, put the values that you want, and it just should work. We'll see how it works for us. And then another thing, even if it's all the thing about containers and microservices in that containers, and we ended up writing some YAML, that the problem with debugging interactions between microservices. Look at this code. most probably your code running in Kubernetes will be full of these REST or maybe gRPC communications. We're calling another microservice by the DNS name. That's what Kubernetes provides us out of the box. So, excellent. But how do we test? So first thing, unit tests. This is excellent. I can mock, I can spy, I can use stub. But only thing I can do actually is use my assumptions about other microservices. My assumptions maybe made with my talk with the other developer yesterday, maybe with the design doc, but most of the times, quite frequently, my unit tests pass. But once I deploy it in a remote cluster, something fails, because different microservices behave differently now, probably because of the fast iterations. Okay, how about local debugging? We can use local Kubernetes cluster, Minikube, Docker for Kubernetes, or maybe even Compose. Some people choose Compose over local Kubernetes cluster because it's maybe a little bit simpler to configure. But again, yeah, you can try to run all of your microservices locally on that cluster, but it needs a lot of resources. And what about cloud APIs, cloud ML, cloud AI, cloud vision, cloud text recognition? You won't be able to do that in your local cluster. And even if you were able to run it on a locally, everything in your local cluster is still kind of remote, and you still need to build those dreadful container images. So in the final one, you can do everything in development Kubernetes cluster, which should be identical to your production cluster, which is a great way to do 12-factor application. One of the 12 factors says dev prod parity, and this is a great idea. But if we deploy, for example, with git push and CI/CD, if we deploy to development Kubernetes cluster, again, how do we debug? Can we look inside of that cluster? Communications maybe with the cloud databases. There's a lot of work actually to do that. We need to run your microservice in debug mode, edit your YAML files, use a new version again, push, then pull and wait for the updates. There's a lot of work to run your microservices in a debug mode. So that's a lot of frustration. They thought for a minute and thought maybe cloud native is not that exciting. But they are really smart, and they found cloud code for IntelliJ, and it's also available for VS Code. Well, I know this is a stupid question because IntelliJ was in the presentation title. Who is using IntelliJ or JetBrains IDEs here? Oh, yeah, almost everybody. What about VS Code? Anyone using VS Code? A little bit less people. Nice. Okay. So it turned out the cloud code allows us to build those cloud-native applications much easier and almost without using those CLI tools. We will integrate them for you and give you more time to focus on writing and evolving your code. So now, demo time. For now, I will play a little bit of impersonation theater. I will be one by one those developers. And we'll start, before we go, this is again the picture. There's a front-end service in Kotlin, Vault service in Java and Spring Boot, and notification instance service in Node.js. So, let's start. Let me know if it's too small. How does it look? Can you see? Bigger? Okay. So this is a front-end service. So our first Java developer turned to be Kotlin developer, developed this simple thing just to serve resources. So it turned out to be really easy, and Kotlin is famous for its DSL, domain-specific languages. So he just uses routing and static. For the root, he serves index HTML. For results, he serves results HTML and uses embedded server, which is netty. Excellent. It runs locally, fine. But we need to deploy this to our Kubernetes cluster. Our Kubernetes cluster is already set up for us. It's running on a Google data center in Frankfurt. It has a lot of memory, but not that much, probably 12 gigabytes. That should be more than enough. So what do? First thing, we need to create a Docker file to containerize this application. So that's what he quickly wrote. This is a terrible Docker file because it needs you to first build application somewhere locally on a build system, and then it copies a jar file, and then it invokes Java. Well, at least it's better than some Docker file that does the copy and from Ubuntu and installations. So Then we need to do, and before we start, here are the preferences and plugins, Cloud Code and Kubernetes from IntelliJ. They're all available there. So, the simplest way to deploy to Kubernetes is to create a deployment and service to expose the endpoints. Let's do that. Deploy.yaml. The only thought of writing that YAML from scratch gives me shivers. So I will use this Kubernetes deployment live template from Kubernetes plugin from JetBrains. It's just dep. Voila, that's it. I will call this front end service. And image, I'm going to use Google Container Registry. This is my project. And again, the name will be front end service. So the replicas are one, but since we're going to use this actual application, I will put it to free. So we'll know it's always available. That's it. And now we need to expose the endpoints. For it, we need a service. svc.yaml. Again, I will not write YAML from scratch, but I will use those live templates. Kubernetes service, kserv. I will also know that it's called front-end service. For port, we're going to use 80. And type is cluster IP. And the target port is actually 8080. That's the only bits of information I need to know. It's pretty easy. At least I don't have to write YAML. So, for now, I will go to Cloud Code Tools, Cloud Code. This is the menu you get when you install Cloud Code. Add Kubernetes support. 1, 2, 3. And we have new run configurations. Hopefully not too small. One of them is called continuous deploy, and it's used to quickly iterate on your application. What does it mean? It means while you edit your code or configuration, it will watch the changes on your source files, on your configuration files, even your Docker files. And when this change is detected, when you save it, it will take it, rebuild it, and push it to a remote repository and apply all the Kubernetes manifest you have here. So it takes some time to detect the context, which is supposed to come soon. We also have profiles here. The profile is a way to alter slightly, so it's detected my active context. Now, although it's Frankfurt, it still takes some time. Okay. We will not delete deployments when we're finished, because we know whatever we do, we don't introduce bugs. I hope so. And same for deploy. And we will tail logs of the deployment. So deploy is just a single deployment. What it does for you, it actually detected all the Kubernetes manifests you have in your project. It detected the Docker file, and it will now remove all of the tedious steps. It will assign a new version on each change. It will take it either from GitHub, change number, commit number. It will generate a single, it will generate, I think, a SHA-256 code, or you can just take the timestamp and assign it as a version number. You will never have to think about updating the version. Whatever you do the change, the image will be having a new version, and it will be regenerated for you. Let's see how it works. For now, I'll just say Kubernetes deploy. And it's deployed. But we have a problem because we have a terrible Docker file. And this terrible Docker file, we need to write it better, so I need to build it before I actually use this Docker file. I don't know how to write good Docker files. And why should I? Is there a solution to build great, nice container images for Java? And I think there is, and it's called Jeep. Has anyone heard of a Jeep? Oh, great, great. This is a perfect solution for our problem. Container is just an implementation detail. We don't have to worry about it. We don't need to. Why should I care
If my container is perfectly built, if it's optimized, do I need more than one layer? Do I optimize my dependencies? Do I build more than needed? If my image size is too big, I don't want to care about this. And Jeep will do that for me. Steps: apply the plugin for Gradle 11 and build that. And we don't even have to do that because everything is integrated in Cloud Code as well. So that's the only thing we need to do. Instead of using standard build, we will use Jeep Gradle. And this here is scaffold YAML, another YAML, but it's again was generated for you. We use scaffold. I don't know, have anyone heard of scaffold? No. Oh yeah, great, perfect. So scaffold is really powerful tool that is the backbone of our deployment functionality in Cloud Code. What it does, it takes your configuration and your Kubernetes manifest, your Docker files, or your Jeep project, and tags, pushes, deploys it, and shows you the logs. This is actually what we do here in Cloud Code. Why we chose to use scaffold as a backbone? Because then, even if you deploy from IDE, you can use scaffold later in CI/CD pipeline on the server side. So you don't have to be stuck on your IDE for your deployments. You can always extract this deployment and put it on your CI/CD service as well. So now, instead of Dockerfile, we say use Jeep Gradle. Use this plugin to build. And what we'll do for you, this plugin will detect your project. It will detect what classes we changed, very thinly optimize it, never update dependencies layers when they're not changed, and use the proper base images. They will communicate with container registries, so it's optimized all possible ways. So let's see if it works. So now we see it's doing Jeep containerization. It's building dependencies layers, resources layers, and classes layers separately. It optimized. And it took, I think, and it starts. Perfect. After we deploy, we check the button, show us the logs. So we see the logs from Frankfurt data center right in our IDE. And it seems it's working fine. So the Kotlin developer is excited, and he's telling this Java Spring Boot guy, listen, you got to use Cloud Code and YAML templates. That's perfect. I just clicked the button, and I used Jeep, so I forgot about terrible Docker file, and it just works. And I think the building took 6 seconds. Nice. Well, of course, I built it before, but after the first run, it literally runs in a few seconds. Okay, so the vaulting service, the one in Java in Spring Boot. Everything is here already. I created, this Java guy created deploy and service, just like we did for front-end service, so it's already there. And again, some terrible Docker file. Just copying some jar files. This is not how we're supposed to do Docker files, but we will not need to know, as we know. Just go Tools, Cloud Code, Kubernetes, add Kubernetes support. So the scaffold configuration and run configuration has been generated for us. Let's go and use Jeep instead of a Docker file. Jeep Gradle. No additional configuration. That's it. Let's go and check our configurations. Wonderful. We'll keep our deployments in continuous mode. We want to deploy and see the logs, tail mode. And we're checking that we are deploying to Devoxx demo context. I have other Kubernetes contexts here, like Dockerfile Desktop and Minikube. I could copy this run configuration and deploy locally. I can deploy to other data center. I can deploy to other contexts to test maybe in QA environment. So it's really flexible. You can create as many run configurations in your IntelliJ and deploy to different variations, or maybe use deployment profiles to build it differently. But for now, we'll just deploy it to this cluster. Okay. It just took me 2 clicks. Was it that easy? Let's see. So it's building Java and Spring Boot microservice. Wonderful. Again, separate dependencies, resources, classes layers. Again, a few seconds for build. Deployment created, service created. Again, we see logs from Frankfurt data center. Spring Boot logs. No errors. Start application in 6 seconds. I heard today from the talk that Java is old and fat and slow. I don't know. It feels fast for some reason, even without Graalvm and Quarkus. But maybe it's just too small application.
Okay, so passing along, and poor Node.js guy, he can't use IntelliJ, but he can use WebStorm. And Cloud Code is actually available for WebStorm as well. Here we go. Very simple Node.js application. And so, again, deployment and service YAML files has been created from snippets, live templates. And for now, we can't use Jeep for Node.js because it's not Java. It doesn't have a clean separation between jars, dependencies, resources, and classes. So we gotta use the Docker file. So this is a pretty standard Docker file for Node.js, but maybe something like Jeep will appear for Node.js as well. So, okay, everything is here. Cloud Code, Kubernetes, add Kubernetes support. Boom, it's working. It's WebStorm, and it's working. Again, we are deploying to Europe, Devoxx demo cluster. Excellent. We'll tail the logs. Everything is here. Should be that easy. Why it's not failing? Okay, so now you see slightly different steps. This is actually Dockerfile was building. So this you see, I mean, I obviously built it before, but imagine building it for the first time or changing the big layer. With Jeep, it was much easier, much faster than here, even though the Node.js app is really small. Okay, we got logs from Frankfurt, and again, no errors. Listening. Perfect. Have I used any CLI tools yet? No. No do the magic? No one missed me? No, I haven't opened any consoles yet. Okay, now it's time for demo. It should be working. We bought this cloud service from these excellent, brilliant guys. And we set up this, we'll see later, it's called what-kubernetes. Don't use it yet? It's working. So this domain name uses our static IP address. It points to our Frankfurt cluster, where our small microservices are running, where we just deployed from IntelliJ and WebStorm. Excellent, that should work. Yeah, we just used Cloud Code, Scaffold, and Jeep. Submit, see results. Yes, but we need to test a little bit more. How about this? No, it should be 2 words. Maybe probably with this word. How about this? Oh no, even worse. So as we know from today's keynote, we write code, we get bugs. So what do we do? First thing first. We're working on Kubernetes. We need to understand what's going on there in the cluster. Maybe something is wrong, crashback looping, maybe container is wrong, maybe its version is wrong, although it should, oh, thanks. But it doesn't work, right? Whatever you want. Okay, let's see. I'm gonna cheat on IntelliJ a little bit on VS Code. We have a little bit better debugging on the IntelliJ side, but Kubernetes Explorer is only available on VS Code side for now. But it's going to be available soon, within months or 2, and the next, or maybe the one after next release. So we have here the Cloud Code, and this is VS Code. And this is the my logo. This is the logo on the left. This is a Cluster Explorer. So do me refresh. This is my right next to my code. It's going to be the listing of things that happens here. So I see everything is green. Pods are green, deployments are green, services are all there. This all should be there. And if I need to edit a YAML and see on the YAML level, I can just click this little edit button and I will see this YAML. Well, replicas are free. Everything is here. So back to IntelliJ. There must be something wrong with the actual code. Oh no. So, we see it's running. So, what can we do now? The perfect way would be just hit the debug button and see what's going on right there inside of that data center in Frankfurt. The other way would be adding a log statement, another log statement, another log statement, rebuild and check the logs, rebuild and check the logs, but hitting the debug button would be so good. Let's see if we can do that. So those 2 guys, Kotlin and Java guys, well, probably use JavaScript. Probably an error isn't there. I mean, it's not even typed language. Probably something's wrong with you. And he goes, okay, I will quickly check. So he put a breakpoint here and switches to continuous deploy. Look at this. We have a debug button available. Let's try it. So what it does, it, under the hood, for you, it modifies all of your Kubernetes manifest, entry points in your containers, to run your Node.js application in debug mode. Then this container image, modified specifically for debug purposes, is put again, tagged, versioned, and put on remote container repository, and then run in your actual remote Kubernetes cluster. So we see Docker file is much slower than zip, but still okay. Whoa, the debug panel opens, and thank you, someone used it. I don't have to do that. So let's see what's going on. So here we have the post, and this is notify method. This is called by voting service, which is supposed to send us the current state of votes. Let's see what we have. I'm seeing a meeting and update. I think this is right, because update is what WebSocket uses once we have new votes, and all users, all connected to the results web page should receive it. So when previous votes should save the state. Let's see, previous votes, Jeep 1, this couldn't be true. We get so many votes as of now. I guess the voting service doesn't send us the correct information. It should send us the accumulated voting result, but not just, one vote. So JavaScript guy is really happy. He used the debugging. It took him one click of the button and look into the internal state of the cluster, and he says, most probably front end is kind of static now. Maybe the voting, our brain is wrong. And voting guy have to agree. And now we stopped our debug mode, and all the temporary images that we created on your machine, on the developer machine that used it, were deleted, so you don't have a lot of garbage. So let's go back. Voting service. How about debugging the Java application? It's possible. Let's try it. So if someone has this, now we'll, let's wait. I think it starts. Let's take the logs. You can always see the logs here. Excellent, excellent. Okay, I see some votes coming. Excellent, great. So now I'm putting, no one will have any votes more coming, because I'm putting a breakpoint in a single replica of my microservice. Yep, thanks, someone hit it. Let's see what's happening here. So now, again, what happened behind the scenes for us? This Java application has been converted into debug mode. The debug port, Java Debug Wire Protocol, JDWP, has been connected to IDE. The special image has been built. We don't have to do anything for it. Everything was done by Cloud Code and Scaffold and a little bit of Jeep. So, and we're now inside of the Frankfurt cluster state. It feels almost like I'm hacking through elections. And being Russian, it feels weird. Okay, let's see. I got votes, and I got new votes. New votes for some reason is empty. Okay, you see, votes are actually not 111. It actually has pretty decent amount of numbers. What's going on here? So we're adding account. New votes, for some reason I get an empty lab. Okay, so here, a notification. Rest template, new votes, and notification response from notification. So what do we get? Notification response, what did they got? They got nothing, because why? Oh, I know why. Because instead of accumulated votes, I'm just sending them new votes. In this case, someone just submitted nothing. That was the reason. I should have been more careful. And probably I should log this notification response from my notification microservice so I could use logs better and actually understand the state of an application better. Excellent. I think that's the only bug I have, maybe, for now. I stopped my debugging session. And now I will run the continuous mode, just run it in a normal continuous way. So if you remember, I described it as a mode where you can make changes, and once you save it, Cloud Code will detect it, rebuild, retag, repush, and redeploy it for you in a cluster. Let's do that. So unfortunately, for simplicity of the demo, the vote service is stateful, and all of our votes are currently erased, but it's okay. Once we fix it, we should be good. Okay, I think instead of votes, new votes, I should just send votes. So I save, and once I saved, look at this. It picked up the change. We're again rebuilding, setting container entry points, 6 seconds to rebuild the whole container image with all the dependencies, and we're restarting the Spring application. The old replica has been stopped and killed, the new one starts. Okay. Okay, we'll go, let's go. Solved. We're going some votes. Okay, let's see. Look at this. It's working. Now, it's time for everyone to pick up their phone and vote. What do you think you use, or going to use, or would like to use from this list? Oh, I like it. Looks good. None of the above. I don't like it. Excellent. By the way, the Cloud Run, I think I never mentioned, but here it's in the list. The Cloud Run, I think it makes sense for you to take a look at this, because we saw like the way to use snippets to quickly create the YAML files for our Kubernetes. Cloud Run is an offer from Google where you just need to run, to have your application, no YAML files, and with the help of Jeep, just throw this Java application into a cluster, and it will just spin it up for you. Even scale to 0. Scale as you need it, provide more resources, and do things like this. So let's pause for a moment. Maybe it's all set up. Maybe I did something dirty magic. Let's add another option. What do you think? I have 2 ideas. Maybe Kotlin, maybe GraalVM. What do you think? Maybe anyone has an idea? What can we vote for? Another option. Maybe 2. Node.js. Okay, sounds good. Let's do GraalVM and Node.js. So everything is running perfect. We got logs. Excellent. We don't need them anymore. Let's go to front end. This is where we have our stuff. Node.js 0. And by the way, it should be available once I make these changes. It still should be available. GraalVM 0. All right, and here in index, we need to add this as well. So what was it? Node.js. Okay. Yeah, I think they match. Okay, I save. Let's see. Redeploy, because I wasn't running continuous deployment, but it's okay. It's almost the same. And let's see. It's building. A few seconds. Everything's ready. Container is updated. It's deployed. Excellent. And Kotlin Gator started pretty fast. Exciting. Let's go and see. We got new options. I'm voting for both of them. Seeing results. I like those guys. Not bad. I think we need to buy this voting service from them. It's actually working. Cloud Code, 300. Thank you, guys. Thank you. I'll make a picture of it now, and I'll show it to my manager. Keep going. Who wrote the script? That's how you know developers are in the room. All right. Lovely. Let's recap what we just saw. So we have those 3 developers with a brilliant idea, and they decided to split into 3 microservices, use different technologies. The only question they have, what is cloud native? What is the best way to work with it? So they start prototyping, and we saw that working with containers, the whole development loop with containers is tedious and kind of boring and repetitive, prone to mistakes. And YAML is even worse, writing things like separated by spaces. And they found Cloud Code and were able, in single click, to deploy or continues to deploy the application. They use snippets to quickly create standard YAMLs. And then they also use continuous deployment to quickly add new features or fixes to the application, save and quickly redeploy. And last but not least, they actually used live debugging right on the cluster, remote cluster running in a data center there in Frankfurt on the Google data center. And they saw what's going on in that cluster and were able to solve the issue without adding any more logs, specific instructions, refactoring the applications, sorry, even without unit test. This is not what we're supposed to do, but they fixed it even without any testing. So, to recap, this is what we have in Cloud Code in general. You can work with any Kubernetes cluster. Kubernetes is wonderfully vendor neutral. This is one of its major strengths. You can use local Kubernetes cluster like Minikube or Docker for desktop if you don't want to pay for remote cluster or you don't have your own Kubernetes cluster set up. You can use any cloud with support for Kubernetes, AWS, Azure, or GKE. The profiles, we haven't looked at them really closely, but you can use profiles to build custom set of YAMLs, to use Helm, to use customize and things like that. There's not a single way to use your run configuration. You can deploy in multiple ways. Container builders, Jeep for Java, just excellent, or Docker, push to Docker Hub, Google Container Registry, AWS Registry, everything is supported as long as you authorize it right. Cluster browser, this one is not available in IntelliJ yet, but it's coming, and I showed it you in VS Code of things. Debugging, Java is working right now. Node.js, it's working. I showed it a little bit future release. It's coming probably in the next week or 2. Go and Python, we have a lot of support, a lot of requests for Go debugging. I think it's coming to maybe within a few months. Editing, well, except that YAMLs, the standard YAMLs, we have support for Knative, serverless, the customize. More is coming. We will support Istio, Cloud Run, YAMLs, and deployment. You saw we already talk about this. Deployment, continuous, manual. We can always use Cloud Build, which is one of the things we also support in Cloud Code. This is supported by Scaffold and Cloud Code. This is Google's Cloud Build, where you build your image on the cloud instead of a local machine. This is how you get Cloud Code. That's pretty easy. IntelliJ, Cloud Code is available on JetBrains plugins repository, and issues are tracked on GitHub. You can find them easily. Please file issues, feature requests. It's all pretty new. We're still in sort of alpha beta, so please, your ideas, your thoughts, your concerns. We're listening. We're very actively maintaining the GitHub issues tracked on GitHub. Cloud Code VS Code is available from VS Code Marketplace. And this is a QR code that links to our docs. Visit Google booth. It's here, I think on the first floor. I think Google is hiring. And now you're all Kubernetes masters. And even without using CLIs and a YAML, it's even better, right? And thank you. Dziękuję. Thank you very much, Kubernetes masters.
Okay. That was Ivan Portyankin with his talk, Be a Kubernetes Master Without Ever Leaving Your Code Debugger and IntelliJ. Does anyone have any questions for Ivan?
Yeah, questions, please.
Okay, just a sec. I'm going to get a microphone down here real close.
Oh, by the way, I have some Cloud Code stickers. So please come and...
Actually, 2 questions, not very related one to each other. First, is it Kubernetes specific, or does this support OpenShift too?
So Kubernetes, you mean OpenShift, the not Kubernetes implementation of OpenShift? Or, I mean, we support any Kubernetes implementation, as long as you have properly configured kube control, kube config context.
Well, I mean, OpenShift is still a bit differs, the CLI commands, all that stuff.
Does it work with kube control? Can you control it with kube control?
Can't say right now.
Okay, so if it works with kube control, with standard Kubernetes CLI, we will work with it in Cloud Code.
Okay, and the second question was about the Docker files, all these continuous deployment and debugging deployment. Does it pump all the images through the remote Docker repository?
Yeah, it does, and it tries to remove them once you're done. So, for example, if you work in continuous mode and you build more features, so another container, another container, another container, as you iterate and you try to do something, it apparently builds a new container for each iteration. But once you stop it, it tries to remove it locally and from remote repository, so it's not, stuffed and with garbage that you don't need anymore.
Thank you.
Yeah, welcome.
Any other questions here? Anybody has a question at all? I mean, related to this topic, obviously. Nobody? Nobody? No.
Yeah, someone in the middle.
Oh! Let's just 1 second here. Who is it? Oh. Okay.
I have a question. Do you plan to support Helm as well?
We do support Helm on a basic level. So you can use profile in scaffold YAML to add a custom deployment. So instead of kube control deploying your YAMLs, you can use Helm and specify some parameters for Helm. And we plan actually to better support Helm editing, Helm YAMLs, and maybe templates. So yes, but now you can use it as well. Take a look at the scaffold schema, scaffold documentation. You can do that. You can do that the same way. Probably not without debugging, because we can transform the YAML manifest with Helm, but to deploy, definitely.
One more, maybe? Just one more? Two more? One more? Nobody else?
Everybody wants to get some beer. I want to.
All right, Ivan, thank you very much.
Thank you. Anyone wants stickers? I got some stickers.